Hey, how's it going? This is Tony Dubiel. If you haven't tuned into the previous videos, to give you a brief introduction, I am a technical solutions architect working for Cisco Cloud and Managed Services Organization. In our previous videos, we had session one, which was a overview of Intercloud Fabric Business Edition use cases to give you an idea of why to use the product to connect the private cloud to a provider cloud environment. Secondly, in the other session, in session two, we went over how Intercloud Fabric works with a deep dive into the components and how the Intercloud Fabric Business Edition can orchestrate connecting the private cloud to the public cloud and how it provides automation for securing the connectivity as well as providing other networking services and layer 4 through 7 services to create a tenant environment as an overlay on top of the provider cloud infrastructure as a service. If we look to the left here, we see the components of the Intercloud Fabric Business Edition software stack, as well as the virtual appliances that are instantiated as part of providing the integration from both the customer premise data center with the virtual machine manager, in this case a vCenter, as well as the switching components, the Intercloud extender, which provides the virtual Ethernet module to provide layer 2 integration into the 802.1q environment in virtual switching environment, as well as port groups on the customer premise. The ability to provision a tunnel to a cloud provider. In this case, in demo 1, we'll focus on AWS. Secondly, we will build out the environment and take a look at the ICS switch that has been uploaded and provisioned in the AWS cloud, which also includes a CSR Lite router for layer 3 functionality. So again, ICS is a virtual appliance that creates a virtual Ethernet module which abstracts from the IaaS the compute environment to run as a virtual machine, but ultimately it creates an overlay of layer 2 that is transposed on top of the AWS private VPC environment. If you're familiar with AWS, you realize that the way that networks are delivered to the end customer, the tenant, is in a layer 3 only environment. So they provide an elastic IP that is reachable from a VPC subnet, but at this point in time, there are no true layer 2 services available to a tenant in AWS. By incorporating Intercloud Fabric Business Edition and connecting and integrating into the AWS EC2 environment, we provide a layer 2 overlay on top of an AWS layer 3 environment, which translates to the ability to support additional protocols that natively would not work in AWS, such as multicast. In addition to non-supported protocols, because Intercloud Fabric Business Edition has ported over some of the features and capabilities of Nexus 1KV switching, virtual switching product, we can also support additional features from the ICS switch as part of creating an environment, a layer 2 environment on top of the AWS layer 3 environment. In other words, you can leverage features such as ER span to remotely span a port from a VLAN, so you can capture VLAN traffic, perhaps to analyze that traffic in a tool set such as Wireshark, or to feed that traffic to other management software that resides on premise but would give you visibility into the traffic patterns, the actual traffic that has been encrypted, because the switch port would reside within that layer 2 subnet that has been connected via the VPN to have visibility into that traffic, into the content of that traffic. In addition to ER-span, there is also NetFlow. So any of the virtual appliances that are installed on the provider cloud side, if they have NetFlow capabilities, then they can, certainly provide that data to a collector as part of, enabling those features from Cisco product perspective. Lastly, I wanted to point out the routing capabilities. In this case, in AWS, we have the CSR capability, Intercloud router. That is a part of a CSR Lite capability, which means that it provides layer 3 routing and gateway services for the VLANs that have been extended to the provider cloud. In this case, we have 2 VLANs, one for a web tier that I've created a web virtual data center as a logical way of configuring and organizing the cloud environment. I also have an application tier that I've created for application servers as part of an application virtual data center. Having a router allows me to route between those 2 VLANs to localize routing, as well as having the ability to route between those same VLANs on the customer premise by having a router in the enterprise data center as well. So if the MAC addresses of the virtual machines reside in the provider cloud, then as they ARP, this router will either send them to the switch port if they're on the same VLAN, or would route between VLANs. If not, it would allow that traffic to pass through to the local area network on the other side of the tunnel here, and then ultimately would route between the customer's own router. In the demo, we will focus on the components of the software stack and how we would use the wizard capability to easily install and configure these components. When we bring up the environment, I'll take you through the wizard and what needed to be configured to configure my lab, as well as take a look at building tunnels to the cloud providers, and then making VDCs available for web and application servers. We will demonstrate migrating a virtual machine, a web server from the customer premise into the provider cloud, as well as migrating it back. We will take advantage of the ability of creating templates that I have uploaded, an application server template with an application that has been pre-installed into a Linux operating system, into a virtual machine that we have uploaded into AWS as an AMI image that has the driver for the VPN adapter for the VNIC that allows for the customer to maintain their private IP addressing. We will spin up a net new instantiation to include the application server that would represent spawning applications for a scale out scenario, which would provide for elasticity or leveraging elasticity in the AWS environment for capacity augmentation. Moving forward, in the future labs, we will take a look at additional use cases. So what you see here is an environment in Azure. We will take a look at that separately in subsequent demos, as well as looking at a use case of integrating Azure environment to the to the private cloud and to the AWS cloud to federate those 3 cloud environments together and allow them to exist on the same private IP addressing that represents one of the customer's networks. Having said all that, hopefully I haven't confused anyone too much, but as we switch gears here and we start to look at the Intercloud Fabric Director user interface as well as the administrative console, I feel that everybody should have a good level set at that point, and it should clarify any questions that you may have at this point in time. Okay, this is the Intercloud Fabric Director administrative console. We'll go ahead and log in here and take a look at how I initially configured the infrastructure, which is the integration of the virtual appliances. and then we'll segue into migrating a workload into AWS and back out of AWS to the private cloud. These configurations right here represent the infrastructure regarding the Intercloud Fabric Director, the Prime Network Service Controller, both of which reside in the same virtual machine but have their own IP address. They operate as separate processes that have been containerized within the same virtual machine. As you can see, we've got 20.7 allocated for the Prime Network Service Controller. We have a vCenter that represents the virtual machine manager as part of my lab that represents a customer data center. And then we have a VSM, which is a virtual supervisor module. That is a component that provides the control plane and the configurations to supervise the virtual Ethernet module. Again, remember, a virtual Ethernet module is a part of a virtual appliance. The ICX, the Intercloud extender, in this case on the customer premise side of the connection. On the provider side of the connection for a tenant, we instantiate a Intercloud switch that would also represent a virtual Ethernet module. So in both cases, those virtual appliances representing AVM are managed by a virtual supervisor module that resides on the customer premise side of the cloud connection. So initially, in order to set these components up, I needed to go through a wizard. Again, the vCenter is a part of that configuration. They needed to be on a common VLAN, in this case 20. I created a pool of IP addresses based on the private IP range that I'm using for that subnet in that VLAN on the customer premise, called infra for infrastructure. From a data center perspective, this would represent the virtual data center as it exists in the vCenter environment. And again, we integrate into that side to have visibility to be able to identify the existing virtual machines as we have the capability of migrating those virtual machines. The host would represent an ESXi host. I've already used the available host in the initial connection, so there's no options for me. And then data store would have represented the data store for storage for that particular host. So obviously we're not going to be able to go any farther in the wizard, but what I'll do is show you the steps as they were completed in the initial install process. An administrator has verbose logging capabilities to go back and to analyze the workflows that have been provisioned from the Intercloud Fabric Director. We access those through organization, and then we click on service request. If I go through towards the bottom here, this represents the initial infrastructure setup. To give you an idea of all of the tasks that were completed, let's take a look at the log files. Okay, so as we scroll down, we'll start to see some of the tasks. Whoa, sorry about that, a little too quick there. All right, so we can see that we started to create profiles for the Intercloud Fabric Director. We needed to extract software, the image, so that was bundled in a tar file. That image included the Prime Network Service Controller. I mentioned earlier that that's implemented into a single virtual machine, but as a separate container in Linux. So we have to build those virtual appliances, and then as we scroll down, we'll start to see some IP addressing that was allocated from our infrastructure pool of IPs with the Prime Network Service Controller. As we work our way down, we can see that we started to implement the Intercloud Fabric Virtual Supervisor module that represents the control plane for our switches, our ICX and our ICS switches. We started to create the virtual machine for that VSM from a template. And as we instantiated that particular component, we were able to continue to move forward with allocating IPs and so on for each one of those devices. The wizard would work through the configuration based on the parameters that we inputted earlier in the wizard example that I shared with you. And then ultimately the workflow would complete. It completed successfully. So that's where the initial screen shows that it completed successfully. And we have our base infrastructure that represents the Intercloud fabric for business. Now let's take a look at the cloud connections. If we are able to take a look here to the left over at Intercloud, and then we would drop down to ICF Cloud. As you can see depicted on the screen, currently I have two existing cloud connections. The first one is a connection to AWS with an Intercloud cloud name of AWS Cloud. In this configuration, it's operational. On the customer premise side, we have a virtual appliance that represents a virtual Ethernet module as well as a VPN headend to provide SSL VPN connectivity to encrypt and secure the layer 2 LAN extensions. This is the ICX, the Intercloud extender, with a private IP address that exists on the management subnet. So 192.168.20 is the management subnet. Similarly, we have a virtual Ethernet module, a virtual appliance that has been instantiated in the AWS side of the connection. In this case, we have an Intercloud switch. This switch uses the public IP address, which is a NAT address that has been allocated based on a private IP address from the VPC, the virtual private cloud, that has been allocated to the tenant, and that private IP from a VNIC that is implemented as part of the hypervisor on the provider cloud side is fronted by a NAT translation. So in order to connect to this virtual appliance over the internet, then we are connecting to 52.6.64.46 in Amazon over the public internet. So we've terminated those two virtual appliances together, and now they have a working tunnel. Hence, we can leverage the connectivity to start moving additional workloads between the two and connecting the two clouds together, leveraging networking services because we are maintaining the private IP from additional VLANs that we've extended into the AWS environment. And in addition to that, we are also providing routing services in the AWS side of the connection to localize routing. And we could have optionally turned on a firewall between virtual machines and VLANs as well. Along these same lines, we have an Azure Cloud connection. As you can see, on the customer premise, we've instantiated a second Intercloud extender ICX switch. What this means is that every tunneled connection requires its own dedicated ICX, virtual Ethernet module appliance and VPN headend. Now, these devices are decoupled from the control plane, which resides in the VSM, a virtual supervisor module that we saw on the previous screen is a part of the infrastructure. For every single VSM that's deployed under an Intercloud Fabric Director, it can support up to 16 of these ICX in tunneled connections total. From the Intercloud Fabric Director scaling perspective, it can support up to 4 of those VSMs. So we have 4 times 16 infrastructure components that can be managed within a single Intercloud Fabric Director that cannot exceed 1,000 VMs. So that's the sizing limitation that we have in the current release. Moving forward in the roadmap, our scalability will increase over time in subsequent releases of the software. So let me give you a quick look at what we needed to do to connect to and configure the tunnel. So to give you an example, We'll just go ahead and start the process here. And let me explain what we're doing. So we're either connecting to Amazon, Azure, or Cisco Intercloud services. This option would be available to connect to Cisco's cloud or one of our alliance partners who are offering a Cisco Intercloud services node as part of the Intercloud in our ecosystem of Cisco-powered Intercloud providers. At this point in time, I did not have an account yet to connect to this, but that's something that I am working on. So expect to find a future demo focused and dedicated, specifically on how to connect to Cisco Intercloud services. At this point in time, we have Amazon and Azure in my particular demo. Okay, so the next thing that we would need to have is our credentials. In AWS's case, we would have a provider account name, and then we would also have a key, an access ID, an access key that we would need to have readily available in order to connect to the tunnel, because this credential is used when we make an API call to build out that environment. So in order for us to have access to EC2 infrastructure as a service resources, we need to log in, and then ultimately our account would be charged against the resources that we used in a metered manner. So at this point in time, I'm not going to throw my credentials, expose them in this video. But if they were in here, the next step is that we would validate them. Upon validating them, we would select the data center. In terms of data centers in AWS, then that would equate to their regions, and their regions have a naming convention. So we would decide which data center, either in the US or globally, that we wanted to connect to in order to obtain resources to bring up VMs or to migrate our VMs into those environments. Having said that, let me take you through a log file of the actual connection from the original configuration of connecting my lab to AWS Cloud. As we drill down into the details here, we can look in the log file for verbose information on step-by-step tasks that were needed to complete in order to bring up that cloud connection. So what we can do is we see that we executed the workflow upon entering the valid criteria, from which we make an API call, log in to AWS, and then we start to look at the IP addressing, the private IP addressing, so that we can configure the virtual appliances that we need in terms of ICX and ICS to complete the configuration of bringing up that secure tunnel. So all of this is orchestrated. It's an automatic provisioning based off of policies that's happening behind the scenes. No need for the customer to configure any of the stuff that you see here. So the next thing that happens is we need to create the port profiles. We need to be on common VLANs and to span the correct VLANs in a 802.1q trunk. So we need that configuration that's a part of the policy. So we will create a trunk profile in the virtual supervisor module to configure those switches as they instantiate and become available as switches in VEMs on both sides of this tunnel. So you can see here that we've created Access 20 is VLAN 20, the management VLAN, a port profile for the AWS Cloud ICS switch. Again, ICS is on the provider cloud side of the tunnel. So moving down, more policies are red. Scroll down a bit. Okay, so once we've completed reading the policies and sharing them through API calls, what you can see here is that we're deploying the ICX switch. This is the local switch. So we are actually creating a virtual machine in vCenter for that virtual appliance to reside on the customer premise. We are using an image that was pre-uploaded into the Prime Network Service Controller. We would instantiate, or actually first upload that image and instantiate it to build an ICS switch in AWS. So that is happening as well. Again, we're still deploying the ICX on the customer premise side. That takes a bit of time. So while that is happening, we are also moving those files and converting those files to an AMI image type in order to be read and extracted into an EC2 workload in AWS. So we again deploying both, and we'll go ahead and truncate a bit. So here we go. We still have many steps here. So we've made some deployment progress. ICX has completed at this point in time. And we are still working on the ICS switch. So the upload has been converted to the provider image. Again, that's AMI. And now we are deploying the ICS into the Amazon side of the connection. So skip down a little bit more. That takes a bit of time. Some of these steps are a bit redundant. Okay, so now at this point in time, we have deployed what we call the IC link. The IC link is the actual tunnel. So once we have a functioning ICX and an ICS, based off of the configuration IP addresses, they become available, and then we orchestrate connecting the actual SSL or DTLS connection, depending on what version of ICF Director. At one point in time, DTLS was the only option that required a UDP or TCP port outbound. With SSL in the current release in 2.2.1, then that avoids any need to poke a hole or reconfigure an outbound firewall rule set. So that would be the preferred method currently. So from building the tunnel, we can see that the next step is that we can start to upload additional services, in this case a CSR router. So the ICS is the switching component, a CSR router with light capabilities in terms of CSR 1000K. It's not full feature set, but it does provide inter VLAN routing and gateway features that are needed for a tenant routing purpose. So that template is being uploaded into the customer environment as well. We have an IC link and we have a router at this point in our cloud. And you can see that it completed. Obviously, in the previous screen, we would not have that tunnel connection without having successfully completed all of those tasks and steps. Policies are important, so I feel we should spend a few minutes here unpacking this. We have several different types of policies. We can configure catalogs and expose them based off of templates and services that we want to make available to the end users based off of their roles access when they log into the user interface, where as opposed to the administrator interface that we are leveraging currently. We also have the virtual data centers. A virtual data center creates a logical data center that we can group our devices based off of policies related to network security, etc. So if we look at the network policies, this is where we would align our pools of IP addresses based on the customer's IP addressing to allocate an IP address to a net new virtual machine. In other words, if we spawn a copy of a virtual machine based off of a template in the provider cloud, we can allocate a private IP address and map it to the VLAN and IP addressing and subnet as it exists currently in the customer's enterprise data center. We have several IP address ranges here. Infra, again, was like our management VLAN for the actual appliances. We have a web for web servers and load balancers. Application servers have their own subnet, dev test, and Q&A, all of which can either route between VLANs if we allow for that in our policies. If we look at the Intercloud network policies, we align those pools of IPs with network policies that we create for specific types of devices that, again, would ultimately roll up to a virtual data center. So let me unpack one of those, if you don't mind. Quickly here, we have a virtual data centers. We have groupings. We can create different groups depend on roles-based access that would expose, virtual data centers based on who logs in. Right now I have a demo cloud group. where all of these reside. If we take a look at any one of these, we could look at the AWS Web VDC. All right, so if we edit that one, we can take a look at that. And what you'll see here is that we've grouped it into a provider cloud. We've allocated a policy. So we have the system level policies that I didn't show you that screen, but that's where we have additional capabilities to add, more granular policies that are system based. So things like instance sizing, like the footprint of the virtual machine. Do we dictate what that size is, or do we allow for the end user to make modifications in sizing to increase or reduce the sizing of the virtual machine? System policies is where we set those types of controls. Network policy is where we allocate IPs. So if we were to add a new policy, we could do that. And the web network policy is the one that was selected for this particular VDC. Again, in order to drill down into that specific web policy, we can go back to those policies where that would exist in network. And here's the web. And then when we start to dig into this, we have these NICs and port groups that we align together to map VLANs to virtual NICs that are assigned to port groups that make sense based off of the type of VLAN and which VDC we are allocating resources in. So in this case, we have the web NIC is what we're using. And I believe this will allow me to drill down into it a little bit more. Or actually, I cannot edit this because it's already in use. But the next layer of configuration would take us into those pools of IP addresses that I showed you a few minutes ago. Okay, so from a cloud perspective, this gives us visibility into the entire environment, from an administrative perspective. And then we have a tool set here that allows us to leverage some of the virtual machine cloud lifecycle management capabilities. So what we will do here, and this will conclude this first demo, is I will migrate one of my workloads, this AWS servers and application server. This is the public IP. This is the private IP. What I will do is I will migrate this to our on-premise data center edition. So as I identify this one, I can select this to migrate to premise. This particular application VDC will be used. This is how we'll keep it organized on our own private enterprise data center. We'll drop it into that VDC, which is on a specific VLAN that maintains that correct IP. It is a CentOS 6.3. This is the particular ESXi host I will send it to with capacity. Actually, I'll send it to this one. A little bit more space on that one, the available storage. If we want to remove the image and configuration file from the provider cloud so that we no longer incur any charges, we would do that. Remove source VM, and we will proceed. Okay, so now that that is in progress, we can check the status. In addition to migrating using the administrative console that we were just looking at, in the next video I will also bring up the user interface in the catalog to give you an idea of how you can migrate virtual machines and leverage templates, catalog-based templates, to import them and to bring them online in the provider cloud. So where are we at here? We'll go in logging files to give you a little more context. We can see that we have fetched the file of the VM image in Amazon. We are powering it off, and we will ultimately go through a conversion process and download the files, then a conversion process to convert from AMI to VMDK, so that way we can bring this virtual machine online from our vCenter and our VMware environment. Okay, so we gave a bit of time for the virtual machine to migrate from AWS back to the enterprise data center running on a private BDC for application servers. So let's take a look at what we have here. So as you can see, we needed to power off the server in AWS. Then we downloaded the image from the provider in AMI format rather. Afterwards, after we converted, we have a VMDK file that we can now migrate to the customer's vCenter environment. So we have scheduled for inventory in the vCenter, and from that we will bring up the virtual machine powered on in our local data center. Afterwards, we delete the virtual machine in the cloud, which is important because if you only power off a virtual machine in AWS, you continue to accrue charges. Once you terminate the virtual machine, then you would decommission that virtual machine and hence would stop accruing any charges for that specific instance. And then what we can see is that we had a successful migration, from which we can take a look at it. If we go back over to Intercloud, compute, and bring up the virtual machines. Again, this is from the administrative console. And there we go. We have the AWS server primary. It is powered on and it is part of the private app VDC. If we want to drill down into that, we can go specifically to that VDC, which is just a logical organization for a virtual data center. From that, we can implement networking and security and so on from policies. So from this, I'd like to stop this video, and in the next session, I'll provide a demo where we will start actually migrating this virtual machine back to AWS, but this time we will use the user interface versus the administrative console. This would be the interface that a line of business, an application owner, a developer, a user from the IT department would have access to based off of their role, but only able to have access to what we expose in a catalog. So we'll start from that perspective, and then we'll take a look at the networking and security interoperability features and walk through some of the use cases we've talked through in the past 2 sessions. I'd like to thank you for your time and hope to see you on the next demo session. Thank you.